All right, so let's start with problem number 6. It says use the diagram of the paper drinking cup to answer the following questions. Part A, how many cubic inches of water will the cone hold? If I'm asking about how much it's going to hold, what is it that I'm asking for? Volume. But before we actually get into finding the volume, there is a typo in this first question, and I'm curious who can find it. Yeah, if you look over at the picture, we are measuring the radius and the height in centimeters, and it says cubic inches. We need to change this to centimeters. All right, so volume for a cone is 1/3 pi r squared times the height. What are we putting in for the radius? 2. So 1/3 pi times 2 squared times our height of what? Times the height of 5. Let's go ahead and calculate that. What is the volume of this paper drinking cup? Feel free to come up and grab a calculator if you need one. 1/3 times pi times 2 squared times 5. 20.944. And that would be centimeters cubed. All right. Somebody earlier today had a question about the height because they're showing the height out here instead of showing it in the middle of the cup. Either way of showing it is fine. It would be similar to if I wanted to measure the height of this cone right here. I would not be able to put my ruler down inside it. I would have to measure it next to it. So either way would be a fine way to measure the height. You just want to go from base to vertex. As long as it goes from base to vertex, that would count. All right, part B. How much paper would be needed to make the cup? What am I asking about now? Surface area, yes. Surface area formula for a cone is what? Pi r times slant height plus pi r squared. Now this is a cup. Have you guys ever seen a paper drinking cup like this? Sometimes they'll be in waiting rooms. They'll have like a big bottle of water on a stand, and they'll have this little tube that you can pull these cone-shaped paper drinking cups out of. Not good if you want to set it down, but just a quick drink of water. Would this entire thing be covered with paper? What part would not be covered with paper? The top of it, which we would call what on a cone? The base. So I want to make sure that we're not including the base because that's not going to be covered with paper. Which part of this surface area formula would be telling me about that circular shaped base? The second part, pi r squared. This right here is the area of the circular base. And that would not be covered with paper, so we're going to get rid of that part. So surface area would be pi times our radius of 2 times our slant height. They're showing that with an arrow over here. And I need to use Pythagorean theorem because the height and the radius are going to form a right angle with each other. So we can use Pythagorean theorem to find that slant height. A squared plus b squared equals c squared. The radius and the height, the 5 and the 2, are a and b. It doesn't matter which one goes where. So I have 5 squared plus 2 squared equals my slant height squared. So I get 25 plus 4 equals my slant height squared. 29 equals cursive L squared. Square root of both sides to get my slant height by itself. Is the square root of 29 a nice, pretty number? No, then we're going to leave it in its exact form here. We're going to just keep it as radical 29 for that slant height. So now I need to grab my calculator. We're going to do pi times 2 times radical 29. And that comes out to be what? 33.836, and that would be centimeters squared. All right. Part C. If a larger cone had the same radius, but a height of 8 inches, how much more water could it hold? Again, if I'm talking about how much water it can hold, what are we talking about? Volume. Well, the height of my paper drinking cup was given to me in centimeters. It was 5 centimeters. We're going to change it to 8 inches, but I can't just put 8 in my formula. When I put stuff in for the radius and the height, they have to be using the same units, either both in centimeters or both in inches. So we're going to have to change this into centimeters. 1 inch is equal to 2.54 centimeters. So if I want to know how much 8 inches is, I can times both sides by 8. Then I would have 8 inches is equal to how many centimeters? You said 20.32? 20.32 centimeters. So here is our new height. So volume, 1/3 pi r squared times the height. Says the same radius, so 2 squared times our height of 20.32. What is the new volume? (85.116 centimeters cubed. So here's our new volume. It said how much more water could this new cup hold? So we're going to do new volume minus old volume to find out how much more. So 85.116 minus our old volume that was 20.944. What do we get? 64.172 cubic centimeters more water. Fantastic. Yes. Yep. What else would you guys like to see? Number which one? Number 3, absolutely. Number 3, we are wrapping this Toblerone chocolate bar. The box is a right triangular prism. So we're going to need to use our prism formulas. The bases are equilateral triangles with side length 4 centimeters. And the box is 15 centimeters long. So I'm going to go ahead and add that to my picture here. This length is 15 centimeters. And then these triangle-shaped end caps here are 4 centimeters all the way around. If that's an equilateral triangle, how big are the angles here? 60-degree angles. Equilateral triangle always has 60-degree angles. All right, part A, how much wrapping paper will she need? What are we asking about here? Surface area. Surface area formula for a prism is what? Go ahead and read it to me off of that half sheet of paper. That would be my volume. Yes, 2 times the area of the base plus the perimeter times the height. What shape is our base? What shape are the bases? Triangles. Here it tells us we have a right triangular prism, so it's telling me the shape of the base right here. Remember, when we're looking at a prism, it's going to have 2 congruent parallel bases. So whichever pieces are never going to touch each other. These rectangles around the sides, those are touching each other, so those can't be my bases. The triangles on these 2 ends are never going to touch, so that's how I know those are my bases. So these are triangles. How do you find the area of a triangle? 1/2 base times height. Plus perimeter times height. Do we know the base of the triangle? Do we have a size for the base of the triangle? 4. Yep, we have 4 centimeters. So I have a base amount that I could put in. Do we have a height for the triangle? Do we know how tall that triangle is from vertex to base? No. But because this is an equilateral triangle, this height right here is doing what to my bottom base? Splitting it in half. Now remember, the height always has to be perpendicular to the base. So here's my height. Since it cuts it in half, this would be 2 centimeters here and 2 centimeters here. So could I find the height? Yeah, I could do Pythagorean theorem to find the height. There's an easier way though. We can absolutely do it this way, but I feel like we know another way of finding the area of a triangle. Does anybody remember the other formula to find the area of a triangle? 1/2 AB sine C, where A and B are sides of the triangle, and C is the angle in between them. Do I know at least 2 sides of the triangle that I could put in for A and for B? Do I know how big the angle is in between those 2 sides? So I can use 1/2 AB sine C, and I can just plug my numbers in right now without having to do Pythagorean theorem. You can absolutely do 1/2 base times height, but you're going to have to do Pythagorean theorem to find the height here. All right, so let's sub in what we've got then. Surface area is equal to 2 times 1/2. How big are the sides? 4, so times 4 times 4 times sine of the angle between them. How big's my angle? 60 degrees. Plus perimeter times height. Perimeter of my base. What is the perimeter of the base here? Not 4, each side is 4. 12. This is an equilateral triangle, so it would be considered a regular polygon. 3 sides, 4 centimeters each side, gives me a perimeter of 12. Times the height, this is the height of the prism. What's the height of the prism? 15. It looks like length when they have it laying down like this, but when we talk about the height of a prism, we're always looking at it as if we stand it up on one of those bases. Let me drop my triangle here. So if I stand it up on one of the bases like this, then my height would be here. So I would take that box and stand it upright. All right, let's calculate each of these sections. Let's find the area of those 2 bases first. 2 times 1/2 times 4 times 4 times the sine of 60 degrees. 13.856 plus 12 times 15, 180. So for my total surface area, we're going to add those 2 together. So I have 193.856 centimeters squared. How much chocolate is contained inside the box? What am I asking about? Volume. And how do we find volume for a prism? Area of the base times the height. Let's go ahead and calculate the area of the base the same way we did up above. 1/2 AB sine C times my height. So I would have 1/2 times 4 times 4 times sine of 60 degrees times my height of 15. And then we pop this in the calculator. 1/2 times 4 times 4 times sine of 60. Close your parentheses, then times it by 15. We get about what? What do we find for our volume? I got something bigger than that. I got 103.923 centimeters cubed. Let me see if I can help figure out what we're on. Oh, you did 1/3 instead of 1/2.
I'm not supposed to. Oh, you said just that.
Yeah, so that's for a pyramid. Oh, you're down here and you were typing that in. Yeah. Yep. So yeah, you got that one right. I think you were just reading that one off. All right. What else would you guys like to see? Number 1, and Abigail, you wanted which one? Number 5? All right, let's do number 1 and then number 5. Number 1, how much pineapple does their current can hold? So I'm asking about volume. Volume of what kind of a shape? Cylinder. How do we find the volume for a cylinder? Pi r squared times height, the area of the base times the height. Well, they tell me over here that there's a height of 10 centimeters and there's a diameter of 8 centimeters. So what's my radius? Four, thank you. 4 centimeter radius. Thank you, sir. Volume equals pi times 4 squared times our height of 10. And we get a volume of how much for the can? 502.655 centimeters cubed. Find the amount of aluminum needed to make the can. So I actually have a can right here. I'm going to take the label off so that we can see this a little bit better. Where is the aluminum? Everywhere. On the inside? The aluminum fills it all up? The inside is left hollow, right? That's our volume amount, what we fill it up inside with. What am I asking about if I want to know how much aluminum is needed to make the can? Surface area. Do I want to include everything in my surface area formula for the aluminum? Yes, I have my lateral area. That's this space, the body right here. And the top and the bottom are made out of aluminum. So what is my surface area formula for a cylinder? Two pi r squared plus 2 pi r times the height. So 2 pi times my radius of 4 squared plus 2 pi times my radius of 4 times my height of 10. Let's do this one piece at a time. 2 pi times 4 squared would give me what? $100.531 plus 2 pi times 4 times 10. $251.327. Then we add those two together to get our total surface area of 351.858 centimeters squared. All right, part C, find the amount of paper needed to make the label. So this can that I just held up a moment ago, I have cut the label off of this one so I can hold it up. When I cut the label and hold it out flat like this is what shape? Rectangle. How do you find the area of a rectangle? Length times width. So I need my length, I need to know how long it is here, times my width, well, that would be this. This is the height of the can, so that it goes from bottom to top. This side of the label has to fit perfectly around that base. So it needs to be the size of this circle right here, so that it goes all the way around. What do we call around a circle? That's my circumference. How do we find circumference? Pi r squared would be my area, but that's close. How do we find the circumference? 2 pi r. That's okay, not the squared part. 2 pi r is my circumference. So I need 2 pi r times the height of my label, which would be the same as the height of my cylinder. So I'm still looking at surface area because it's still on the outside. But when I'm looking at this right here, which piece of that would I use for the label? Second part, 2 pi r, that would be my length, and then the height. This first part, 2 pi r squared, well, pi r squared is how we find the area of a circle. And it's 2 pi r squared because I have 2 circles, the top and the bottom. So to find my label, I want the lateral area only. So my lateral area is 2 pi r times the height. So 2 pi times 2 times my height of 10. And we've already calculated that. That comes out to be how much? 251.327 centimeters squared. All right, last part of the question. They are considering a new design for this can. It's going to double the height. What effect will this have on the amount of pineapple the can will hold, the amount of aluminum needed per can, and the amount of paper needed for the label? So if they double the height, what will the new height be? 20. New height is 20 centimeters. Nothing else about this can is going to change. So let's find our new volume. Volume, pi r squared times the height. So pi times my radius stays 4, so 4 squared, times my new height of 20. So what would the new volume come out to be? (1,005.31), right? Centimeters cubed. Compare that to the old volume. What happened to my volume? It doubled. If I take this right here and times it by 2, this is what I get. So my volume doubles. Two times 502.655 gives me this. All right, the amount of aluminum needed to make the can, that would be my surface area. 2 pi r squared plus 2 pi r h. Does anything change about this first part, the 2 pi r squared part? No, so that's still going to come out to be 100.531. 2 pi times my radius of 4 times my new height of 20. What does that come out to be? (502.655). Then we add those two together. My aluminum would be 603.186 centimeters squared. Old amount of aluminum was 351.858. Did it double the amount of aluminum I needed? If I take this times 2, will I get that? Try it. See what happens when you put it in your calculator. Stop it. If I do 351.858 and I times it by 2. No. So it gets bigger, but it didn't quite double, right? Surface area gets bigger. But doesn't double. All right, and then the amount of paper is our lateral area. My lateral area is just the 2 pi RH. So 2 pi times 4 times my new height of 20. Again, we've calculated this already. That was this part right here. So my lateral area is 502.655 centimeters squared. The old amount of paper we said was 251.327. Is that double the amount of paper now? Yes. We had to round this one. We had to round that one. So it comes out like when I just take this number here and double it, I get 502.654. Close enough. We're going to say that it doubles. If I hadn't rounded it, if I had kept it precise, it would exactly double. So amount of paper doubles. Nicely done. All right, number 5 was the next one I was asked for, so let's go check out number 5. So we have a rocket here. It says how much should be how many. I'm going to change that. How many cubic feet of payload or cargo could this rocket hold? I'm wanting to know how much it can hold. What do I want to know about it? Volume. This rocket is made up of what 2 more recognizable shapes? Cone and a cylinder. So we're going to do the volume of the cylinder plus the volume of the cone. It doesn't matter whether you do cone then cylinder or cylinder then cone since we're adding them together. Volume of a cylinder we just did. That's pi r squared times the height. How about the volume for a cone? Mm-hmm. 1/3 pi r squared times the height. You're welcome. In the picture, they show me that this is 80 feet. What is that? What are they showing me? They're showing me the diameter. So what would my radius be? 40. 40 feet for my radius. And then it shows me the height of the cylinder right here, 120 feet. So we have everything we need to find the volume of the cylinder, pi times my radius of 40 squared times my height of 120. Let's go ahead and calculate just that volume. Pi times 40 squared times 120. What do we get? It's a big number. You started it off correctly. (603,185.789). Now we need to come and do the cone. 1/3 pi. What's the radius of the cone? Still 40. And now this h, I need the height of just the cone. Well, the height of the whole thing is how much? 180. So what would the height of the cone be then? 60. Because 60 plus 120 gives me 180. So 1/3 times pi times 40 squared times 60 gives me what? 100,530.96. I rounded to 965 when I did mine. If you round to 964, I'm not taking off any points. So to find our total volume, the total payload would be 703,716.754 cubic feet. We have 6 minutes left, which is enough time for one longish problem or two very short problems. What would you guys like to see? Which one? 15. Let's go look at 15. Find the volume and surface area of the following hexagonal prism. So we have a prism here. Volume for a prism is area of the base times the height. How do we find the area of a hexagon? How do we find the area of a hexagon? No, that'd be if it's a square. One half apothem times perimeter. That's how we find the area of a regular polygon. So I have 1/2. Do I need to go and find the apothem, or did they give it to me? They gave it to us. Yay! Right here is my apothem. So I'm going to put 4 in for the apothem. Times the perimeter of the base. The perimeter of my base, it's a regular polygon, so number of sides times the length of each side. A hexagon has how many sides? 6 sides. Each side is how big? 3.6. And while they didn't include it, the apothem has inches on it, so this would also need to be inches. What is 6 times 3.6? 21.6. Thank you. So there's my perimeter. So times 21.6 times the height, which would be what? 14.9. Multiply all of that together, and we get a volume of how much? (643.68 inches cubed). 643.68 cubic inches. And then they also wanted us to find surface area. Surface area for a prism is 2 times the area of the base plus the perimeter times the height. Since we have this regular hexagon, we find the area of the base by doing 1/2 apothem times perimeter. So I have 2 times 1/2 times 4 times my perimeter of 21.6 plus my perimeter of 21.6 times my height of 14.9. All right, so let's find the area of those two bases. 2 times 1/2 times 4 times 21.6 gives us what? 84.6. I thought I could have written it down. 86.4. Honestly, I transpose numbers so frequently. I was like, did I do that wrong? And then we need 21.6 times 14.9. $321.84. And then we add those two together to get our total surface area of 408.24 inches squared. All right. We got less than a minute for the bell. I want to show you guys very quickly. The answer key is already posted in Canvas. You need to go to Modules, and then you need to scroll to today's date in Modules. And then you'll click on the page right here that says Review for Module 12B Test Day 2. Also, really important, answer key is all the way at the bottom. Question number 14 was approached in a way that is very different than anything that we've done. It's not using anything that you don't know how to do, but we haven't looked at a problem that's exactly like that before. First period asked about problem number 14. Watch that video for problem number 14. It will be very beneficial for the test tomorrow. Hope you guys have a fantastic rest of your day, and I will see you for your last regular test tomorrow.